All right, students, so we're looking at critical numbers today. So this will be your assignment on your off test day, due Friday. So let's get started. So today we want to look at what a critical number is. So this will move us into the next, so-called chapter of what we're doing in calculus. So let's get right to it. So we say that x equals c. So x, a number, right? X equals a number, is a critical number of a function, right? Any function, if when you plug in that value for x, that your original function does exist, and one of the two things are true. So either the derivative is equal to 0 or the derivative doesn't exist. So basically, what you're trying to do is, a critical number is when you set the derivative equal to 0, or you find where it's undefined. And those numbers for x, those would be critical values or critical numbers. Now, the problem is that if you get a let's say you set the derivative equal to 0, right? Or you make the derivative undefined, right? That's how you make the denominator equal to 0. If you get a number and you plug it back into the original function, and it makes the original function f of x undefined, then that's no longer a critical number. So your critical number has to be that when you plug in your critical number into the original function, that original function does not become undefined. So we'll have an example in here of what we mean by that. But basically, you're just setting the derivative equal to 0, or you're finding out where the derivative doesn't exist, which you would take the derivative and make the denominator equal to 0, right? And those are your critical numbers, unless the situation that I just described happens. Okay. Well, let's look at some examples. So, problem number 1: find the critical numbers, if any. So again, your function does not have to have critical numbers. So, but we'll definitely be using this going forward because the critical numbers can tell you something about the graph of a function. So, again, right, we're starting anew, and if you can't find a critical number, then it's going to be tough going forward, right? So, fresh start. Let's see what we got. So, notice, right? So let's take the derivative, f prime of x, right? That's equal to 2x minus 3. Okay. So the derivative here is not undefined anywhere. Remember, polynomials are defined for any x. So if you get a polynomial, it's never going to be undefined. So you're good, right? So there's no place where 2x minus 3 can be undefined, so we're not worried about that. So we're just going to make it equal to 0, right? We're going to solve. We're going to add 3 to both sides. 2x equals 3. Divide by 2, and x equals 3 halves. All right, so that's a critical number. Okay? And since, again, if I plug this x back in here, right, it does not make it undefined. Remember, because polynomials are defined everywhere. So this is a critical number, x equals 3 halves. Now, to find the point, right, you would plug in the y. So you have x equals 3 halves. All right, so all right, so x equals 3/2. That would be your critical number, okay? And no need to find y, we're just going to find x. All right, let's try this next one, number 2. All right, f of x equals 1 over x. So now notice, right, this function is going to be undefined at x equals 0. So if we get 0 for a critical number, it's not a critical number because that would make the original function undefined. So let's find f prime of x. And remember, f of x can be rewritten as x to, or 1 over x. Be written as x to the negative 1. So this is negative 1 x to the negative 2. Negative 1 over x squared. And remember, to find a critical number, you make the equation equal 0 or make it undefined. Okay, so this function can never be 0 because the numerator is negative 1. So that doesn't work. Now, how do we make this function undefined? Well, we set the denominator equal to 0. So we get x squared equals 0. Take the square root, we get x equals plus or minus 0, which is just x equals 0. But, again, this is not a critical number, okay, because it makes f of x undefined. So your answer would be no critical numbers. Okay? All right. Okay. So let's go to number 3. All right, so again, if you get the idea right now, remember, you're making the derivative, you're finding the derivative, finding out where it equals 0 or where it's undefined, okay? Okay. All right, so let's find the derivative, 3x squared plus 2x minus 1. Okay, remember, this is never going to be undefined because it's a polynomial. So we're going to make this equal 0, okay? And now we're going to have to factor. Hopefully it factors, right? So we get 3x and x, and then minus 1 plus 1. Okay, so that does work out. And we get x equals 1/3 and x equals negative 1. And now remember, the original function, this is a polynomial function, so this function can never be undefined. It doesn't matter what x you plug in, right? It's always going to spit out a number. So x equals 1/3 and x equals negative 1 are our critical numbers, okay? So basically, if you start off with a polynomial, you know, you're pretty much good. But, you know, things with fractions, or, you know, original functions, f of x with fractions, you be on the lookout, okay? All right, let's do one last one. All right, so you're going to find the critical numbers again. So let's take the derivative, f prime of x, 3w squared minus 2w. Okay, we're going to make that equal to 0. Factor out a w, we get 3w minus 2. So w equals 0 and w equals 2/3. And those are our critical numbers. And again, right, if we look up here, again, another polynomial function, that's never going to be undefined. So these w's are definitely critical numbers, okay? Okay, well, that's pretty much it. That's all we got. We're just gonna, that's just a quick overview of that. And, you know, we'll continue, we'll keep going with this. We'll do some harder functions, but just to get your feet wet, we want to start with that. So I hope you have a blessed day, and